Well, good afternoon. This is 4-2 Greatest Common Factor, which we also call the GCF. So what I want you to do is go ahead and take a few minutes, hit pause, and copy this information down. So go ahead and do that. And so when we talk about common factors, okay, they are factors that are shared by two or more numbers. So for example, we have 8 and we have 6, and we can list the factors. 1 times 8 gives me 8, and 2 times 4 gives me 8. And then for 6, I have 1 times 6 and 2 times 3. The 1 and the 2 are the common factors of 6 and 8, and the common ones again are what we have shaded, or excuse me, what I have circled, the 1 and the 2. Those are the only numbers that are common, and again, those are common factors. Factors, again, are the numbers that multiply together to give you a specific product. Okay? Now, the greatest common factor, again, is the largest of those factors that are common. Okay? So we had the common ones were 1 and 2. It's the greatest common, which again is 2 in this situation. Okay? Let's look at the next slide. There are two different ways you can find greatest common factor. One is what we just did, and that was listing the common or listing the factors, then you simply compare them. So for example, I have 8 and 12, okay? And what I like to do is start with my 8 and a 12, which would be, start with the 8, and we have 1 times the 8. And I work my way from the outside to the inside so that I don't miss any factors. So then I try 2. Does 2 go into 8? You say yes. 2 times 4. And then I say, does 3 go into 8 equally? And it does not. So then we go to the next number, 4, and 4 is already here, so we are done. Okay? So then for 12, we have 1 and 12. Then we start with the next number, which is 2. Does 2 go into 12? Yes. 2 times 6 gives me 12. Then you try 3. Does 3 go into 12 equally? Yep. 3 times 4. And then we say, does 4? Well, we already have 4, so we are done. And you can see how you work your way to the middle so we don't miss any factors. Now you're trying to find common factors. So we have 1, the 2, and the 4. And the greatest common that we have when we list the factors is this largest number, which is 4. Okay? Now the other way is by using prime factorization, and that's using the factor tree. So you simply do the factor tree, which again in this case would be 2 times 4, circle the 2 because it's prime, and then 2 times 2 gives me 4, and they're both prime. Then for 12, use it 6 times 2, 2 is prime. 2 times 3 for the factors of 6, and they are both prime. So now you can compare, and we have 1, 2, 3 2's, so there's my 3 2's, and then I have 2 of my 2's and a 3, so 2, 2, and a 3, and we then circle what's common. So my 2's are common, this group of 2's are common, those two do not have anything common. Then you take what you have, this stands for a 2, this stands for a group of 2, and 2 times 2 is 4. Now, listing factors for smaller numbers sometimes is easier. If we have larger numbers, larger digits, then doing the prime factorization many times will work better. Okay? One other thing is if you don't have anything that's common amongst these, for example, I have 2 times 3 and then maybe a 5 times a 7. Since there's nothing common, there's only one number that will always be common, and that is 1. As you see up here when we list them, we always have a 1 because of 1 times itself. Okay, so if we were comparing 6 and 35, that's what this right here is what equals the prime factors of it. Then we would end up just with a common factor of 1 to be my GCF. Okay. So find the greatest common factor for each set of numbers. So I'm going to let you do this, and you can do it either way. It doesn't matter which way, whatever you feel the most comfortable with. Go ahead and do that. So we'll hit pause and solve. Well, I'll do the first way, which was listing our factors. And so we have 1 times 18. Then we have 2 times 9 gives me 18. Then I try 3, and 3 goes into 18 6 times. Then I try 4. 4 doesn't go into 18 equally. And then 5, and 5 doesn't go into 18 equally. Then 6, we already have a 6, so we're done. 1 and 30. So I try 2. Does 2 go into 30? Yep, it's an even number. That's 15. Then 3 times 10. Then 4. 4 doesn't go into 30 equally. Does 5? Yep, 5 times 6. And does 6? Well, we already have a 6, so we're done. And then again, we're looking for my greatest common, which in this case is 6. Okay? Now, if I would do my prime factorization, I would have 2 times 9. 2 is prime. And then 3 times 3. And those 3's are prime. For 30, you can use any of them. Again, for the prime factorization, I'm going to use 5 times 6, and then 2 times 3. And now I list them, and I get 2 times 3 times 3. And then I have 2 times 3 times 5. What's common? The 2's and the 3's. 2 times 3 equals 6. Either way works perfectly fine. Now let's look at our next one and go ahead and do that for 60 and 54. Now for this one, since the numbers are larger, I'm going to use, and I think most of you will find in my past experience, most do use the prime factorization. So I get 6 times 10, and then I'm going to break that down to 2 times 3, both prime. And then I'm going to use 2 times 5. Those are both prime. Now I have 9 times 6, and then 3 times 3, both prime, and then 2 times 3, both prime. So I compare 2 times 2 times 3 times 5, and then I have 2 times 3 times 3 times 3. And what's common? 2's are common, 3's are common. So I have 2 times 3. Now someone says, well, can I use these two 3's? Absolutely. It's just seeing what you don't have that doesn't match up above. And 2 times 3 is 6, is my greatest common factor. Again, if you're not understanding, please make note of that, and we'll talk about it further tomorrow. Now go ahead and do that for 3 digits. So go ahead and hit pause and solve. So I have 42, 70, and 84. 6 times 7, 7 is prime. 2 times 3, and those are prime. Now I have my 70, and I'll do 7 times 10. 7's prime. And 2 times 5, and those are prime. For this one, I'm going to do, you could divide by 2 if you wanted to as well, and you say 2 times 42 if you want to break that down a little bit. Sometimes that makes it easier. And then 6 times 7, and then 2 times 3. And so then I list them. 2 times 3 times 7, and then 2 times 5 times 7. And then I have 2 times 2 times 3 times 7. So now I've got to compare what's common. Well, my 7's I have in each one, and yes, it has to be in all 3. 2's are common. And you say, well, my 3's are in these 2. Well, those have to be a 3 in this middle one as well. All 3 have to be common. There's no other ones. So 2 times 7, which is 14. Let's look at the next. And now we have some not exponents, but some variables to involve in this. So let's go ahead and do this. So now I have 15xy and 55y2. So I'm going to do my greatest common factors of the numbers themselves. And I have 3 times 5. And I have, I'll do 5 times my 11. So I circle the 11, circle the 5, they're both prime, and I compare. And I have 3 times 5 and 5 times 11, and what's common are my 5s. And since there's only one 5, you just leave it 5. Okay, there's nothing to multiply. But when I look at my x, y, and my y2, if I compare them, I have x, y compared to the exponent saying that there's 2 y's. Okay, so what's common is just one y. So then it's going to be simply 5y. Okay. If I had another y on here and another y here, then it would be y to the second power, because that means that there's 2 y's. Okay, if you had that situation. But we do not. So my answer again is 5y. Those are my common factors. So let's try one more. Go ahead and solve this. So I have 24 and 6, and so I'll go 6 times 4, and then 2 times 3, they're prime, and then 2 times 2, both prime, and then for my 6 I have 2 times 3. And so we'll compare 2 times 3, whoops, I forgot my other 2's in here, and then 2 times 3, so what's common? Well, I've got a group of 2's and a group of 3's. So 2 times that 3 gives me 6. And then again, comparing what I have up here, I have an A and I have an AB. And what's common are just the A's, so my answer is 6A for my greatest common factor. Again, if you have any questions, please mark those down and bring those up in class tomorrow. And have a great evening, and we'll see you tomorrow.